I grade for that? I got a 67.
It's like, no.
I mean, you know what I got this video.
Right.
Come on. Really? Oh my god.
And
Did you really?
Yeah.
Okay, I forgot now. She just got a higher S than I did.
I'm only missed 2 points. Okay, I don't know.
I missed 9.
Yes.
Do you get-
Because even with the lessons, I feel good with this habit. And I didn't even read the chapters.
I didn't read the chapter.
Yeah, she, yeah, she's.
I think so.
But this time I kind of like looked over some things.
It's just because it's taking us so long to read like 3 chapters. But you read chapter 4 like
And it's only,
last week.
it's only written at
Like beginning.
I don't think so. I just feel like we don't talk about it at all, so I don't know what's
Well, we
happening.
don't like read a chapter like every day. It's like,
I don't like reading a chapter every day.
I hate doing those.
You got the last one.
That's right.
I need to work
Last year.
Dang. I'm like basically done with that.
Yeah.
Oh, you're.
I guess it is.
You were
This one's
taking
good.
like, congratulations and then
Yeah.
just 3 minutes how you sit here and do it.
Yeah, I have, when I sit down and draw, I have to sit out there, else I can't.
That was funny.
That's the problem. I can't do little bits and pieces at a time.
System overload.
Okay.
You have procrastinated and you have system overload. So you have to go like not take a break, that's it. And then you're just like, eh.
But you at first procrastinated.
Yeah.
I am.
You know how it is.
But I just like lose sleep over it.
First period. You're welcome.
Before we jump into anything specific, does anybody have questions on the molarity worksheet? This review sheet that I handed out. Anything specific?
I think I'm being really dumb, but
Probably not, but
I don't, I'm confusing myself when they say dinitrogen pentaoxide. I kept getting both of them to have a negative charge, but that doesn't make sense.
Where is this?
Oh, sorry, it's on the back page, letter D.
this is number 21D. Pay attention too, because if anybody else asks a question on 21D this week, I'm going to be very unlikely to offer help, since I'm offering it to everybody here, so pay attention. Dinitrogen pentaoxide and water. Let's put H2O. Get ahead of myself. Yields hydrogen nitrate. Before putting down the formula for any compound, I think it's advisable to make the choice as to whether or not the compound is ionic or covalent. You can tell if a substance is ionic because it's a metal and a non-metal, or possibly a polyatomic ion and a non-metal, or a metal and a polyatomic ion, or a polyatomic ion and a polyatomic ion. If you have a polyatomic ion, it's got to be ionic. Listen to yourself say the word polyatomic ion, ionic. Covalent is always a non-metal and a non-metal. Always. I bring that up as a particular point because when you look on the periodic table, there are not many non-metals. So covalent should be the easiest to identify. And if it's not covalent, then it's going to be ionic. And when you look at the periodic table, like I said, there's only so many of them. Let's think, this is going to be a challenge for me with nitrogen. Wait, carbon is on the line. Yeah, so nitrogen, oxygen, fluorine, sulfur, iodine on the line? The zigzag line? No. Yeah, so we can go, we can actually go over here, there's more. There we go. Carbon, phosphorus, selenium, iodine, and water, or excuse me, and hydrogen. So any substance involving these guys is not only going to be covalent, but remember the naming system, this is the one with the prefixes. That's another sign. If you ever see the prefixes, it's a covalent compound. The formula is told to you in the name. Dinitrogen, 2 nitrogens, pentaoxide, 5 oxygens. Done. We don't have to think in terms of ions because this is not ionic. When you name ionic compounds, remember, you name the metal, and then you name the non-metal, and end it in IDE. So we still have the IDE ending here, but the prefixes immediately tell you covalent. And the prefixes also immediately tell you what the formula is. So this guy plus H2O yields hydrogen nitrate. Now, when you see nitrate, polyatomic ion should be hitting you upside the head. Nitrate, NO3 minus. And as soon as you say NO3 minus, minus means charge, charge means ion, ion means ionic compound. Hydrogen, go to the periodic table. He's going to form a +1 charge. Put those things together, you have HNO3. Balance. Excuse me. So there's going to be coefficients in these balances. But at this point, we at least have the formulas. So I think that answers your question. And I tried to answer the question in a way that's going to help everybody too. Covalent compounds, you hear the name in the prefixes. You can also tell that it's covalent because it's a combination of 2 nonmetals, and that's a telltale sign of covalent. And if it's a covalent compound, the prefixes suggest the formula. There's no sense of looking at the charges because you don't actually have charged particles. You have electrons being shared to form your bonds. Any other questions? Skylar?
I have a general question.
Yes.
When it asks for the mass of a mole, in your answer, do you have to put like grams per mole or do you just have grams? It's on those 30 pages.
Yeah, if it asks specifically like the mass of 1 mole, just give that in grams. So we're talking here, Skylar's asking a question about like 15. When it asks for the mass of 1 mole of O2, just, give that in grams. Yeah, there's no need to say grams per mole because it specifically asked you for the mass of 1 mole. So it's assumed to be 1 mole. Just like in the next problem, it's 16, it asks for the mass of 2 moles of H2SO4. That again, just give in grams. Because that you don't want to say grams per mole because the grams per mole is going to be misleading because this is 2 moles. So I don't want to know what the mass per mole is, I want to know what the mass of 2 moles is. Yeah. Other questions? Skylar?
I also was confused on the last 3 questions, or like 17, 18, 19, but if you probably explain more, I'll probably figure out what that one is.
Well, let me try to offer some general assistance here, because this is kind of a general question. All of these things say add STP. at STP, there is a specific characteristic of gases that is true. At STP, 1 mole of any gas occupies 22.4 liters of volume. This conversion is gold for this section. Since we're at STP in every problem, we can always make a conversion. 1 mole is 22.4 liters, or 22.4 liters is 1 mole. And that conversion is going to help you lots. For 18, where it says density, you're going to have to go back to your old school equation, but density is mass over volume. So what I would do in that problem is just consider a 22.4 liter sample as your volume, and then figure out what the mass of that is. That'll be your numerator. That'll be a little bit pretty simple. That'll be pretty simple to do once you just plug in the mass and plug in the volume. But you use this factor. This is great for those problems. Any other questions?
On the 17 and 19 one, I used like the Pertner equation, and I didn't use 22.4. Does that mean I did it wrong?
No, because remember, this fact comes from the fact that if you put in standard pressure of 1 atmosphere, and you put in a volume of unknown, you put in 1 mole, 0.0821 as your R, and your temperature, standard temperature is 273 Kelvin, volume comes out to be 22.4 liters. So, you can as well, Olivia brings up a good point, use Pertner to solve these problems. And if you use Pertner, the only thing to remember is that R is 0.0821 liter atmosphere over Kelvin mole. So that tells you what units you have to be in. Volume must be in liters, pressure must be in atmospheres, temperature must be in Kelvin, moles must be in moles. But if you do that, then you're golden. So I'll just put a star there to keep that in mind. Yeah, that's a good point there, Olivia. PV equals nRT works for this. Any other questions?
Bless you.
Bless you. Going once? Going twice? So. Friday, your worksheet's due. And on Tuesday, there's a test. On chapters 12 through 14. Let's do another freezing point depression problem. You can put your worksheets away for now. You'll have time to work through that the next couple of days. Well, let's do another freezing point depression problem to get a feel for these things. So let's imagine that 50 grams of sodium nitrate is dissolved in 100 grams of water. What is the freezing point of this sample? The freezing point depression constant for water is 1.86 Celsius degrees per molar. If we just know the molarity of the solution, we're done. If you know the molarity of the solution, you know each molar number decreases the freezing point by 1.86 degrees. So let's find the molarity. If we find the molarity, we have the temperature, which is what we're asked about. We're asked about the temperature. So let's go after the molarity. Moles of solute over liters of solution. Let's first go after the solute. What is the solute in this problem? What is the stuff that's being thrown into our solvent?
The sodium nitrate.
Correct. So when it comes to the solute, here, let's set it up in a nice organized fashion. When it comes to the solute is the sodium nitrate. We know we have 50 grams of sodium nitrate, and we want some number of moles. That's really our question. That's really where we're heading. We want to get some number of moles. So let's work towards that. If we have grams and we want moles, the thing that's going to get us there is the periodic table. But before we even go to the periodic table, we're going to have to know how sodium and nitrate come together. I guess that's going to take the periodic table to do that, because sodium is in the first column, so sodium is going to form a +1 charge. Nitrate is a polyatomic ion. His formula is And as you say negative, as you say minus, think ion. So as these things come together, it's going to be a 1-to-1 ratio, NaNO3. If we use the periodic table, we can find how much 1 mole weighs, which tells us how many moles we have in our 50 grams once we do the conversion. So we're going to have 1 sodium, 1 nitrogen, 3 oxygens. 1 sodium is 1 times 22.99. 1 nitrogen is 1 times 14.01. And 3 oxygens is 3 times 16.00. I'm going to add that all up.
Just a wreck.
I know, the video's shaking. So 22.99 plus 14.01 plus 48, 85. Notice we have slightly less than a mole. 50 grams versus 85 grams. To do the conversion there, start with what you've been given, 50 grams. We know there's 85 grams in 1 mole. Now we know how many moles we have of our solute. 0.588. it's basically a ratio. If 1 mole is 85 grams, and we have 50 grams, do 50 divided by 85, that'll tell you how much of a mole you have. 0.588 moles. So numerator, moles of solute, 0.588 moles. Denominator. Let's try to find the liters of solution. We know we have 100 grams of water. One gram of water has a volume of 1 milliliter. So 100 grams of water has a volume of 100 milliliters. Hop the decimal thrice, 3 hops, 0.1 liters. H2O, done, 0.1 liters. Now we can come up with a molarity. 0.588 divided by 0.1, boom. 5.88 molar. That's the molar concentration of our solution. Now, that's the molar concentration of sodium nitrate. But what's going to happen to our sodium nitrate when it drops in the water? Olivia? Yeah, Olivia gave me the universal hands of, it's going to break apart. Holly gave the exact same universal hand symbol, like this. It's going to break apart. So, when you put your NaNO3 into the solution, it's going to turn into a sodium ion and a nitrate ion. So what you started with, there was only 1 particle, ends up as 2 particles. So if what you started with had a concentration of 5.88 molar, what you end up with is going to have a concentration of 2 times that. Because on the left we have 1 particle, on the right we have 2. When we dropped it in, it was dropped in as a single particle. Once it fell in the water and was dissolved, it now became 2 particles. So our concentration of our particles is going to be 2 times 5.88. Why? Because when we break apart into our sodium and nitrate ions, there's going to be 2 ions, right? 2 ions, twice the concentration. So do the multiplication. 5.88 times 2, that's 11.76. 11.76 molar. And what is that? 11.76 molar is the concentration of the particles in the solution. And that's important. It's important because now, if we know the concentration of the particles in the solution, we can answer the question of how has the freezing point been depressed. The freezing point is depressed at 1.86 Celsius degrees per molar. So, if we've moved if we have a solution of 11.76 molar, we've moved 11.76, 1.86 Celsius degree units. Set that up as a conversion per molar, 1.86 degrees Celsius. Molar cancels with molar, and 11.76 times 1.86 is 21.87 degrees Celsius. That's how much the freezing point has been depressed. What is the normal freezing point of water? 0. So if we've been depressed 21.876 or 21.87 degrees, our freezing point is negative 28.87 degrees. Which is pretty darn impressive if you ask me. The fact that you can take the freezing point from 0 to negative 22. That's the difference between school cancellation and having school. Yeah, right? Yeah, I'm upset at Curtis Smith too. He put way too much hype into her story. I think Curtis Smith secretly just wants his kids to.
Holly was
like-
right yesterday. She said,
It's like,
they always do that.
Yeah, they talk it up.
I
Get everyone hopes up.
think Curtis Smith secretly just wants like his kids to like him. This is my theory.
You know what I don't like about him is that he's in the Lexus and Mercedes commercials and he's like, just $400 a month. And I'm like, everyone makes that much.
Is that what you make for making these bold predictions? in
Sure,
your house?
yeah.
Yeah.
I could get up there and point to things and say 30% chance.
Right. Because
Yeah.
like, it's not like he's actually calculating the numbers, he's just
It's
getting
the
them.
Viper tracker.
Yeah, like the National Weather Service is doing all the hard work, he's just getting it like on a screen and just, he's basically just like a spokesperson, right?
Yeah, for NOAA.
At this point. And he gets, yeah, anyways, I think secretly he wants his kid, like, I think his kids get excited when they don't at school.
If anybody
And I think-
lives in his neighborhood, we're just kidding.
Yeah, right. Everybody knows him personally. We don't know him personally, but we're just basing it off of his professional.
I met him though, like.
Did you?
You guys know the skinny guy? The real skinny guy on the news?
Oh, and I was like, hey, Jerry.
Mark played ultimate frisbee against him. He would like throw the frisbee, catch the frisbee, and he'd be like, I see that coming.
They never hear the commercial.
That's great.
She
Oh.
does you. It never happened. I was so mad.
Hey, we should get free yogurt. Right? Right?
It's such a cheesy commercial though. He says like, he's like, come to yo-yos, and we all say, come to yo-yo.
I have to admit, I saw Curtis Smith once in public, and it was so surreal. It was so surreal, because it was like 11:45 at night. So the newscast had just recently ended, because they do like the 11 o'clock news, right? And the entire news crew came into this place where I was at, which I'd never been to before. I had friends of mine, we met at like this place called Chevy's, which is like way down southwest.
You
And
shouldn't
it-
throw
it's like,
punch
and
them.
Oh, yeah.
it was so surreal. Like, everybody on TV that you've seen before is like sitting at this one table, and then Curtis and one guy are playing pool in the corner with like this huge beard. It was really weird. It's hard not to stare. Yeah, his beard.
Oh, no.
It's like, yeah, it's like the grossest piece of
It's
fish.
disgusting.
Yeah. Do you remember the beard?
What beard?
Curtis Smith's beard?
I've only lived here for, I don't know. Oh, yeah, when he didn't shave?
Yes.
Yes, last
Like,
year.
I'll shave when it's 70 degrees.
I was like, shoot.
Yeah.